signs is sine A over lowercase a equals sine capital B over lowercase b equals sine C over lowercase c. So your vertices are your capital letters. They are your angles. Okay, so when you say sine of capital A, that's talking about this angle right here. The side that corresponds with that, the lowercase a, is going to be across the triangle from that angle. All right, so you can see here, angle C is across from side C. Angle B is across from side B. All right, so it's a sine of an angle over the side across from it. You will never use law of sines in this form. You will always pick two pieces of it, right? We can't solve an equation that has three equal signs in it. So what you're going to see is you might have sine A over A equals sine B over B. Or you might have sine C over C equals sine A over A. You'll have two of those pieces equal to each other for this. Does this look familiar? Have you seen law of sines before? Okay, Gabby says yes. Most of you look like probably not. The cool thing about law of sines is it can be used on any triangle. You can use it for right triangles. In fact, a lot of students who never learned regular trig very well don't ever use regular trig anymore. They just use law of sines. It will still work for right triangles. So we can use it. You could use law of sines on that whole worksheet that you just did, and you would get the answers right. So that is one other reason that I'm not spending a lot of time reviewing that, because if you don't know how to do it well, that is a deficiency that may hurt you in some places, but you can get by, at least for what we're doing in this class, by using law of sines instead. So you can use it for any triangle. It does not have to be a right triangle, as long as you have the right pieces. Okay, so let's look at a problem for this. Oh wait, I did not address the suggestive comment at the bottom. So, in Math 2, you should have done triangle congruence theorems. So you did things like side, angle, hypotenuse, leg. Is that like vaguely familiar to you, like showing that two triangles are congruent? When you did that, your teacher should have told you that there is no angle side postulate. There is no, you can't prove two triangles are congruent if you have an angle in the two sides that are not in between those sides. If you write angle side out in its abbreviated form, it becomes apparently clear that you probably should not be writing that, right? It's like an alarm whenever you write angle side right there on your paper. In fact, I'm going to write it a bunch today because it makes you think whenever you see that word there. This is the only time you're allowed to write angle side on your paper without penalty. Please do not do this on an unrelated topic. But angle side is something that we have to watch out for. Because what happens with angle side, the reason it was not a triangle congruence theorem is because angle side, there's two triangles that might be possible, right? And when we say angle side, it's an angle that is not between the two sides that you know. So, for example, if I knew angle A, and then I knew side C and side A, let's say I had these three pieces of information, I would have an angle, but it's not the angle between two sides, because there is a side angle side. If you have, like if I had, so this would be an angle side situation right here. If I had a triangle where I knew angle A right here, and I knew side C, but I also knew this side right here, this would be a side angle side situation. You have two sides in an angle, but that angle is the one between those two sides. This is okay, although you're going to have to use law of cosines on that, not law of sines. But we'll talk about that in more depth later. This is okay. This you got to watch out for. Okay? If we have this case, if we have angle side side, we might have what we call an ambiguous case triangle. Okay? So an ambiguous case triangle is going to be a triangle that has more than one answer because it could look two different ways. So we have to watch out for this as we are doing these problems. So at the beginning of every problem, you want to ask yourself, do I have an angle side side triangle? And if you don't, that's a good thing because you don't even have to worry about ambiguous case. But if you do, then I'm going to show you what you need to look out for there. So here's our first equation, and our first triangle, and we have an angle here, and a side. Do I have an angle side side triangle here? No, I've got two angles and a side. Angle, angle, side. So we are good on this one. There is no ambiguous case. So we don't have to check for that or anything. So if you've got two angles, that's always going to be what you've got. So we can go ahead and start setting this up. What we need are angles and the sides across from them. So we've got B is across from side B, and we've got A is across from this 3 over here. So we got two of those, and we're going to put them together. C we're going to ignore for this. We don't need C, and we're not trying to find C. So I could say sine of 37 over 3 equals sine of 68 over B. Okay, you could switch the sides of the equal sign on that. It would be fine if you said sine of 68 over B equals sine of 37 over 3. That's fine. It doesn't matter which one comes first. You can even flip these. Our law of sines could be A over sine A equals B over sine B. Like you can put the signs on the bottom as long as they're both on the bottom. I wouldn't suggest it, but you could, because it's just a proportion that you're setting up. I wish that they taught proportions later than they do because they teach it in middle school, and I don't think students understand them well enough. How do we solve a proportion here? What could we do? You got two options, really. There's one that's easier than the other. This is really just like a rational equation like we've been doing, right? So you could get common denominators if you wanted to, like a 3b here and a 3b here. You could think of it that way. But because this is just one fraction equal to another, one of the ways you solve proportions when you were doing proportions way back in 7th grade is you cross-multiplied there. So that is going to give you B times sine 37 equals 3 sine 68. Or again, switch side of the equal signs. It doesn't matter as long as your B is with your sine 37 and 3 is with the sine 68. And then we're trying to solve for that B. And remember, sine 37 is just a number. I could type it into my calculator, which for some reason I closed. Why did I close my calculator? Knowing good and well we were going to need this. All right. So if I type, I wouldn't do it yet, but sine 37 is just a decimal. All right. So I'm just going to divide it off. And so then I can do 3 sine 68 divided by sine 37. And that is going to give me 4.622. So B is 4.622. And that would be our answer here. That's the length of our side B. Something to keep in mind to help you check your answers or make sure your answers are reasonable on this. Bigger sides are always across from bigger angles. So we could see 37 degrees, the side across from it was 3. So we would know the side across from B would need to be bigger than 3 because our angle here is bigger than 37. So, and this fits well here. Okay, questions? All right, let's continue on. Okay, some of the problems you're going to get are not going to give you a picture of the triangle. Instead, they're going to tell you something like triangle PQR, and then they'll give you lowercase p's and measure of angle p's. If you see this M, I've typed it and I don't have an angle symbol. It would really look like this, measure of angle P. So you'll see this like in textbooks. That means measure of angle P equals 120. So I'm going to just draw myself a triangle here. And I'm going to put P right here because lowercase p is 28, so that needs to be my bigger angle. It really does. I'm going to put Q right here and R right here. And so Q, side Q is going to be 22. That'll be right across from my Q. And then angle P is 120 degrees. They have asked us to find the measure of angle R. This is what we're looking for right here. Can we find the measure of angle R right away? Okay, we cannot because we don't know the length of the side across from angle R. However, if we go over here and find angle Q first, which we can do because we've got the side across from it, then it's going to be very simple to find R because we just have to subtract from 180. So once you get two of the angles, the third one should be very easy to find. But I have forgot to check for something here. Okay, I need to first think about what I've got. I've got this angle. I've got this side, I've got this side right here. Is my angle between my two sides? It is not. So I have got angle, side, side. Gotta watch out. Okay, this could be an ambiguous case problem. They give you permission to write angle, side, side on your paper without getting in trouble. It helps you as you write down that word that hopefully you're not accustomed to writing often, I hope. That's like an alarm to your brain, like, oh, I should not be writing that, so I got to watch out for something that's happening here. So we're going to set the problem up just like we did the last problem, but there's going to be a step where we've got to check for ambiguous case, and I'll show you where that comes in. So we just know we need to be aware this could be ambiguous case. So we're going to set up, I've got angle P and side P, so I want to use that. I've got sine of 120 over 28. And then I don't know Q, so I'm going to have sine of Q over side Q, which is 22. So, much like the last problem, cross multiply. This time I'm going to get 28 sine Q equals 22 sine 120. Now this time it's different than it was last time. Last time I had sine of a number, right? I just had to divide it off. This time my Q, that's what I'm trying to solve for right there. So I've got to get rid of the 28 and I've got to get rid of the sine. So to get rid of that 28, I'm just going to divide it off. So I've got sine of Q equals, I'm going to go ahead and type this stuff into the calculator. 22 sine 120 divided by 28 should give us 0.680445. So you want to keep that whole number in your calculator. Don't round it. I'm not going to write the whole thing down, but I'm going to keep that in my calculator. If you want, you can even store it as a variable, but we should be able to do it without storing. So I'm solving for Q. How do I find Q? How do I get rid of that sign? Inverse sine. Okay, so to get rid of a trig function, you have to use inverse of that function, which will be sine for all these problems because it's the law of sines that we're using. So then we're just going to type into our calculator, inverse sine is the blue button and sine. And then I need to use that exact value right there, which I could type in, but the even better way to do it is if you do second and the negative key, it says A and S, which is the answer from the line before. So that was second and the negative key I used for that. I don't know if you guys have used that before. I'm sure some of you have. But so that'll do inverse sine of that whole number without having to round it at all. And so we get 42 point, I'm going to go 879. Okay. Well, there's two things that make it not quite our answer yet. Number one, were we looking for Q? What they want to find? R. So this is not our final answer because we need to find R. Also, right here is where we've got to check for ambiguous case, which you guys don't know how to do yet, but I'm getting ready to show you. So once you find the angle, you have to check for ambiguous case. Hello? Yes. I do. Yes. We're taking notes right now. I can send her if you need her right now, or I can send her when we get notes done. Okay, sounds good. Okay, thank you. Kendall, whenever we get notes done, the nurse needs to see you. All right, so you have to check for ambiguous case. Here is how you do that. Okay, so to check, you are going to do 180 degrees minus the angle you just found. All right, so for this particular one, that means we're going to do 180 minus 42.879 degrees. So it is going to give you 137.121 degrees. Okay? And then you want to see if this new angle will also work in the triangle. Okay, so whenever we found Q, that definitely is a right answer for Q. It should work. But there's a chance that 137.121 also works. We need to go back up here to the triangle. We need to look at angle Q, and we need to think about putting 137.121 degrees here. Would that work for that triangle? Would that be possible? No. Why not? That would add up to more than 180 degrees. You can't have two obtuse angles in a triangle, right? Because if we actually drew those angles to scale, we'd have like something that looks like this instead of the triangles, the pieces of the triangle meeting. So for this problem, we had to check for ambiguous case, but this does not make any sense. It would not work. So this is not ambiguous, meaning that 42.879 is the only possibility for angle Q. It is not our final answer because they weren't asking for angle Q, but it is our only answer for Q. So now all we have to do to find R is we're going to do 180 minus 120 minus that value we got for Q and our measure of angle R is 60 minus the 42.879, which is going to give us 17.121. 120 from what?
From the 137 that we got.
You could, because you've already, it's the same there. Okay, so they were asking for R. This will be our answer. All right, so that problem had the possibility of being an ambiguous case, but it was not an ambiguous case. The first problem had no possibility of being ambiguous. We didn't even need to check because it was not an angle side-side triangle. This one had a possibility. Let's do one that's actually going to be an ambiguous case. These are a pain. I do not like ambiguous case of law of sines. And you will see why when we're done with this problem. So first, I also don't love these questions that ask you to solve the triangle. If you're asked to solve the triangle, that means you must find the lengths and the sides of all of the lengths of the sides and measures of the angles for all of them. So we need to find everything that's missing for this to solve that triangle. So first thing we always want to do when we look at this, we want to think about what information we have. We have an angle, we have a side, we have another side. Is this angle between those two sides? It is not. That would be angle B right there. So we've got angle, side, side. Watch out. Okay. This could be ambiguous. In fact, it is going to be ambiguous. I know that because I've done this one many times, but you would not know that just looking at it. So, what piece of this triangle can we find right now? Sorry. Angle C, yes. That's the only piece you can find right now because you have this angle inside, and then the only other side that you have is across from your C. So angle C is what you've got to look for first. So to set this up, you can say sine of C over 26 equals sine of 70 over 25. And just like we did for the last problem, we're going to cross multiply, we're going to solve for this C, right? So in the first part, there's no checking for ambiguous case. You're just setting it up like you would any problem. 25 sine C equals 26 sine 70. Like the last problem, anytime you're finding an angle, inverse trig is going to be involved. So you want to divide that 25 off first. Get rid of it. So sine of C is going to equal, we'll type this into our calculator, 26 sine 70 divided by 25 is going to give us 0.97728. keep that number in your calculator. And then remind me again, how do I get rid of sine inverse? All right, so inverse sine of that answer is going to give us 77.763. Okay, so as soon as you find that angle, this is when you check for ambiguous case. So what you're going to do is you're going to say, is it possible for C to equal 180 minus 77.763? And when we talk about the unit circle, we'll talk about like why we're doing that. Right now, just sort of take it. These are both angles that have that same sine value, so we get 102.237. So, is it possible for this angle to be 102.237 degrees? It is. And this is whenever your heart, once you've seen a few of these problems, you're like, oh no. There are two answers. So what this means is you are going to have two separate possible sets of answers. And if this was like real world, if you were actually doing a problem where this happened, what you would have to do is you would have to go back to whatever you were measuring and get some more information, because you wouldn't be able to know which one it was. Sometimes you might be able to know because there is a difference between a 102 and a 77, and you might know, well, that's not an obtuse angle, so it's going to be the 77. Like if you can think about picturing what you're looking at, right? But we cannot make any assumptions that things are drawn to scale with pictures. So when we're working out problems like this, we've got to figure out both possibilities. So this is a super huge pain in the behind, because what we're going to have to do, particularly if it is a solve the triangle problem, is we got to solve it twice. All right, so I'm going to kind of split my page in half here. And so we are going to work first from the assumption that C equals 77.763. In fact, I'd like to store that value. Yeah. All right, so if you still have this value right here, I really should have done it. Let me just go backwards. I did 26 sine 70 divided by 25. And then I did sine inverse of that. So really what I should have done right here, this is definitely an answer for C. So I should have just went ahead and stored this value as C. So if you do STO right here and then tell it alpha C, it'll store that value. So when you type C, you're really typing 77.763. So if I want to find all the other pieces, right, B is going to be very easy to find. It's just going to be 180 minus 77.763 minus 70 degrees. And so B, we do 180 minus 180 minus 70 minus C, we get 32.237. Okay, so now we have all of the angles of the triangle. This B right here is 32.237. And so if I have angle B, I can find side B, which is the side that we're missing over here. because we need all the angles and all the sides if it's asked us to solve the triangle. Right now, I'm totally ignoring this 102.237. I'm pretending like it does not exist. Okay. So if I want to find side B, I've got to do law of sines again. I would suggest using sine 70 over 25 as one of your factors, although you could use sine of C over this because you do know that number now, but you don't have to round if you use this instead. And then so sine of B, which is 32.237, divided by side B, which we don't know. I should, right here, because this is angle B, I should go ahead and store that as B. That way I've got it stored in my calculator, so I don't even have to round there either. So if I cross multiply, I will get B sine 70 equals 25 sine of 32.237. And I will need to divide both sides by sine 70. So if we do that in our calculator, 25 sine of, I'm going to use B because I stored my value there, divided by sine 70 is going to give us 14.191. So this is a possible way that the triangle could be solved. But the annoying thing about the ambiguous case is we don't know for sure if these are the answer, because C could also equal 102.237, right? That could be an answer. So I'm switching colors. This is our other option. So basically we just need to go back and do everything we just did over here again, but C needs to have a different value. So if we do 180 minus that C we already had stored, which was that 77.763, that gives us this 102.37. I can store this as now store this as the C. So now we're saying, wait a second, C does not equal 77.763. It equals 102.237 instead. And so we will do 180 minus 70 minus C, and we'll get 7.763. So for angle B, we're doing 180 minus 70 minus the 102.237. So if we have this for our angle C, we will get 7.763 degrees for our angle B. I'm going to go ahead and store that as my B so that I don't have to round that number off. And now I need to do law of sines again. Basically, I'm doing exactly the same thing I did over here, but this time B doesn't equal 32. It equals 7.763. So it's going to be sine of 70 over 25 equals sine of 32.237 over B. No, why did I write that down? What did I just do wrong? I wrote down the B from the other side. B should be 7.763. I'll cross multiply. I'll get B sine 70 equals 25 sine of 7.763. I will divide both sides by sine 70. So B will equal, type this in, 25 sine B divided by sine 70. It's going to be 3.5 594. So what you get for these problems is two separate sets of answers. So you got this set of answers that goes together, that's a possibility, and you also have this set of answers that is a possibility. And the only way for you to tell which one would actually be correct would be to go back and take another measurement, which on a worksheet you're not going to have that option to do. If you were actually measuring out a piece of land or something, you could go back and take another measurement. Okay, questions? Ambiguous case is not super common, but it does happen, and you will see some questions like on a quiz that this will happen for. I think we're going to have our quiz on law of sines and cosines Friday this week. So, let me see. I'm going to skip 6 because it's pretty straightforward. 6 is 17 degrees and 46 degrees, and side C is 18. Is that going to be an angle side side? No, because you have two angles, right? It's an angle side. So it's going to be like the first problem. You would have to solve the whole triangle, but for the sake of time, because I'd like for you to start doing some of these on your own, I'm going to skip that one for now. I want to do one application problem because while your homework is going to be just basically straight triangle problems with no application tonight, I think that it is helpful for you to see like where this would actually apply. I love trig, regular triangle trig with either sine, cosine, and tangent or law of sines and cosines is some of my favorite stuff to teach because it has a lot of applications, particularly with like surveying land or buildings or stuff like that, or carpentry or things like that where you may actually use it. So surveying in particular is one thing where this stuff comes into play a lot. Now, if you know a surveyor or watch somebody that's actually surveying, a lot of their equipment and programs do this stuff for them. So I'm not saying that every person who is a surveyor is working out all these problems all the time. But this is the basis that goes behind it for a lot of the work that they're doing. So when you see people out on the side of the road with those what are those things called? It's on a tripod and you look through it. Yeah. Gosh, transit is it? I don't know. I know that whenever I was in high school, my dad built a gigantic garage. My mom was really mad about it. I'm not kidding. My dad has a garage that will park 12 cars, and has an apartment over top of it that is as large as a house trailer. They have a tenant that lives up there. They built the kind of a garage, yeah. So when he was building this gigantic garage, he did a lot of it himself, and he did all the grading himself because they run a sawmill and they have a lot of equipment, so he could do it. And when he was grading that out, I had to go out there after supper. It seemed like forever. I was probably over-exaggerating because I just didn't want to do it. But I had to go out there and hold the stick. It was this big, long, tall stick. Because he had, whatever it was, this thing. I'm going to call it transit, but I think that's wrong. Something like that. That he would look through, and I had to hold the stick. And then he'd tell me to move the stick. And he'd tell me to move the stick again, and then move the stick again. And then I'd go in for a little while, and he'd get out there and do something, and then I'd have to come back out and then hold the stick some more to see if he had got it level. There was a lot of stick holding that I had to do because of this. And he was not a professional, so we probably did more surveying than needed to really be done because he was not a professional at his grading, but it seemed like it was a long time. anyway, so that's one place where it applies, but doesn't, like, I don't think my dad was like working this stuff out. He was just leveling it, so he wanted to see the same height on the stick all the way around. But we could do something like this, and I have done this whenever I taught geometry before. These are not exact numbers. I made these up. So whenever I taught geometry, we made clinometers. I don't know if you guys did this whenever you guys had math too. Sometimes some other teachers will do it, but I haven't taught geometry in a long time. You can make them really easily. You just take a straw and a protractor, and you can make this little thing, and you look through, and they're relatively accurate. They're not that bad. Or you can download them on your phone. You can download a clinometer on your phone and just like, tilt your phone up so that you're like seeing the top of whatever you're trying to look at, and it'll tell you what the angle of elevation is to that. Again, like fairly accurate, probably not accurate enough to really do something with, but pretty accurate. I used to have this, and I'd have students go around the school and measure stuff, but there's a problem spot that I always wanted them to measure, and that was out here between the band room going down to the gym. There is a giant chimney over there, like super tall. Pay attention to it if you have not over there. You guys know where I'm talking about, the really tall chimney? So you got this big tall chimney here that I think goes to some sort of boiler system or something at the school, and is maybe part of the reason why that weird pipe is going down to the gym. Y'all ever paid attention to that pipe? I had not. I've gone down to the gym 1,000 times, and my husband's like, why do they have? Because they got a pipe just like coming out of the real school that just goes overhead. It's just like a pipe this big around. It looks kind of, it's not the classiest looking pipe, just going down there to the gym. But I think something about that pipe and something about this chimney and who even knows what else all hooks in together. They're moving some pipes right now in the old art room because it connects to somehow those pipes that are in the old art room are in the way of something that goes in the elevator of the new gym. To me, those are not close enough for that. But there's something there. Maybe they'll move that stupid pipe. I don't know, but maybe that one will be gone. But anyway, the problem with this chimney is that there's a fence around it. So there's a fence around it because it's got like transformers or something. There's, like there's equipment back here that does something with the heat and air. I don't know what. But there's a fence around it, so you can't measure all the way to the base of the chimney. If you could measure all the way to the base of the chimney, you could just use regular right triangle trig for this. But unless you were like one group I did have one year that found Miss Brown and had her unlock the gate and let them measure all the way to the base of the chimney, then you can't measure to the base of that chimney. I had to outlaw them getting around it because I wanted them to do law of science this time. So this is what you're going to have to do. So Aspen and Gillian look up at the chimney. They find the angle of elevation to the top of the chimney to be 56 degrees. So what they're going to do is they're going to like stand out here somewhere, and the angle of elevation is going to be 56 degrees. Then they are going to step back 2 meters, or however far. It doesn't really matter as long as they measure how far they step back. And they are going to take a second angle of elevation right here, and they find it to be 54 degrees. Okay? We need to know how tall is the chimney. So what we're looking for is we're looking for the height of this chimney, and we'll call it H. Now, this triangle right here is a right triangle, and we could just use regular trig for it if we had enough information. But do we have any information for that triangle other than the angle? We don't know any of the sides of that triangle. So we are going to have to use this triangle, but we're not going to use it first. Instead, what we can do is we've got to look at this skinny triangle right here. Okay? This skinny triangle, we know one of the sides. We do not know all of the angles, but we could find all of the angles. Okay, I know this angle right here is 54. Does anybody know how I could find this angle right here? Perfect. Those are what we call complementary, supplementary angles. Complementary adds up to 90. Supplementary adds up to 180. So we could also call them a linear pair. And so we do 180 minus 56, which is going to give us 124 degrees right here. And then we could subtract those two from 180, which will give us this little skinny, teeny tiny angle up here, which is going to be 2 degrees. So then we have all of the angles of this triangle, and we know one of the sides of this triangle, so we could find any of the sides that we want to. So you have options here on which side you want to find. You could find this side right here, which I'm going to call X. Or you could find this side right here, which I'm going to call Y. It does not matter. You can find either one, but you only need to find one of them. If you find X, then you will have to look at this right triangle right here in order to find H, because that is one side of this. If you find Y, you will look at the big triangle on the outside, because you really have 3 triangles here. You've got this one on the left, the one on the right, and then the big triangle that includes both of them. So I think I'll find X right here. But you could find Y. It's only going to slightly change what you're doing for this problem. So X is across from 54. So I would say sine of 54 over X equals, which pair, angle, and side do we have that go together? 124 and Y do go together, but we couldn't have 2 variables there. So the 2 and 2 is what we're going to have to use. So we will have sine of 2 degrees over 2. Okay, is this angle side? Do we need to be worried about that? We do not. We have all the angles of that triangle. So when we have all the angles, you don't have to worry about angle side. So we're going to cross multiply. We will get X sine 2 equals 2 sine 54. And then we'll divide by sine 2. So 2 sine 54 divided by sine 2 will give us X is going to be 46.363 meters there. But that is not our answer. That is the slanted side right here that I have, that I call X, right? So I don't want to know X. I want to know H. So now I'm going to quit looking at the skinny triangle, because the skinny triangle here does not include H. Now I'm going to look at my yellow triangle right here. Okay? This is a right triangle, so we can use regular trig for it. We do not have to use law of sines. So since it is a right triangle, H would be my opposite side, and X that I just found right here would be my hypotenuse. And I would be using 56 as the angle, because that's the angle in our triangle. So opposite and hypotenuse is sine. I would do sine of 56 equals opposite over hypotenuse. So H over the X that I just found, 46.363. And then to solve that, I would just multiply both sides, 46.363. And so if I take that number and multiply it by sine of 56. I'm going to get 38.436. Now, what I actually find students have the hardest time with is that last step. Because we have started doing law of sines instead of regular trig, and you forget how to do regular trig. Or maybe you never knew it all that well in the first place. That is a possibility. Now, let me show you. You could use law of sines on this. Okay? So if you want to, you can do sine of 56 over h equals, the other angle you know here is sine of 90 over that x, which is 46.363. You will get the same answer if you do this. You will get h sine 90 equals 46.363 sine 56. The reason that you get the same answer is because sine of 90 is 1. So when you divide by sine of 90, you are really just dividing by 1. So it's the same as doing what we just did, and you'll get that same answer right there. So if you are like, I can't keep that many things straight in my brain, you could just use law of sines for the whole thing. Law of sines does work for all triangles, including right triangles. Yes, I don't know why I put a 40 there. Okay, questions? Now, we're going to do some more of this application stuff, but your homework tonight is just triangles. Okay, so you won't have those that you got to set up like this tonight. So,